Hello fellow neuroimagers, today we're going to cover how to download some files from XNAT. The first way I'm going to show is the manual way, so you'll have to do this way if you collected your data outside of the class. And the second way I'll be showing is the way that I've been working on, and if you collect your data within the class, you can download your data with the second method. So the first method, we are going to want to navigate to the UIowa XNAT server. So if we Google RPAX UIowa, we can find the first link here. Let me see if I can make this bigger. If this will become bigger for me if I ask it nicely. Maybe not. Let's see if I can get this to be bigger. There we go, finally. So go back here. Now on the main page, so we're going to click on the XNAT login. Again, I should mention that I am connected to EDU Roam. So you will not be able to log on to this website unless you're on EDU Roam. I submitted my information, and I forgot what the name of the project that you guys will be accessing data from, but it will have a name. It'll be project : whatever the name of the project that you guys will be working with. And so just to show that, since I went a little bit fast there, when we click on the project, we can see the subjects that we have. So I'll click on the only subject that we have, but you guys will have multiple, so you have to download from each subject. And then I will click on this MR session from the subject. So after I click on the subject, I'll click on the session. And there should only be one session per subject for what you have here. And now I'll go to download images. Okay. So this is the method that you have to use if you have collected data outside the class. And eventually this will load. It might take a little while. And you'll need to do this for each subject. So if you can't tell already, this method can take some time and is not very well automated. But it is automatable if we name our files consistently. So again, we don't need to download the localizer scan, which is just looking for the brain, and the calibration scan, which is just calibrating the scanner for us. And we also want to make sure that we download these PU versions. These are corrected for biases that are induced by our 32 channel head coil that we use for our scans, and so that will reduce the inhomogeneities and the intensities in the images so that we can have a better result at the end. So we'd want to use the PU images and not the actual ones. So you could actually unclick any scan that has a PU version of it. And then you'd click download. Since it's about 1.5 gigs for me, I already went ahead and downloaded it ahead of time, but this will download a zip file that will exist in our downloads directory. So I open the terminal and let's go check out the downloads, and we see that we have a zip file. So I'm actually going to make a directory in our UIowa folder, and I'm just going to call it data. I'm going to do make directory P. I'm going to call this source data. So now I can make multiple directories. That's what the -p allows me to do. So I'm going to move this file into our UIowa data, source data. Okay. And we see it's not here anymore because I moved it. So now we'll cd to that directory ourselves. Okay. So now we can unzip this and see what we're working with. And since it's a lot of data, it will take a fairly long time to unzip the many. I guess it's probably going to be close to 100,000 dicoms that we're unzipping here. So this will understandably take a little while to complete. Alright, and it looks like it's done. So we can cd into the subject's name that we downloaded in their session, and we will get numbers for the scans. So this isn't as helpful for us, but we can, through trial and error and corresponding with what we downloaded from the website, we can see which scan is what. So in the 800 folder is going to be our bias corrected functional image for breath hold task. So I can cd into the 800 dicom and look at all the dicoms that are in there. And what we want isn't dicoms, but what we do want are Nifty files. And so what we'll do to transfer those to Nifty is that we'll use DCM to NIIX. And this has a series of options that we can use to transfer our data. So an example command would look something like this. So I can type DCM to NIIX. Let's say we're going to reconstruct the func bold. So I'm going to look at this, and what we want the -f, which is going to specify file name, and the output directory. So we want the -f to be sub dash 999 sesh active pre task breath hold. I'm just going to mention that was reconstructed with that PU, and this was a bold scan. And then .nii.gz. Okay. And then the output directory, I will want it to be in home brain Iowa data sub dash 999 sesh active pre in the func directory. And that is how I would want that command to be formatted. So now I actually need to make this directory since I haven't made it yet. I do Control-Shift-C, Control-C, and then I will make their P. And then if I cd back one, then I can see that this directory exists. Active pre, cd func. All of that exists. Want to keep in the data, cd source data. Alright. So now I'm going to copy paste that command that I was drafting up here. And I left click, shift, left clicked, and then that selected this entire string for me. Now I can do Control-Shift-C, Control-Shift-V. So after I specify the file name and the output directory, I can now specify the path to the DICOMs. So now I'll select sub, scans, that one was 800, DICOM, all of the DICOMs. Okay. And then it downloaded it for me, or it transferred it for me into the file name that I wanted. Just to confirm, we can cd into source data. Well, not source data. Want to cd into sub. There we go. Oh, and for the naming, I messed up there. I tend to mess up with this step. We do not. Oh, where's the command? We do not actually want this nii.gz specified, since it will append it on its own. So I'm going to select, don't want to select all of that. I'm going to select this again, Control-Shift-C, Control-Shift-V. Now I'm going to rename the file just to that. And if I want it to be zipped, so it'll add the GZ at the end. Let's see what I need. I need -Z, so that will compress my images for me. So I'll add in a -Z at the beginning here. I'll say yes. So do I want to zip them or GZ compress them? I'll say yes. And now we'll run this fixed command. Oh. We need to cd in the source data, because I specified this path indirectly. So now we'll run that. And that will give us the result that we wanted. So I'll just remove the sub .gz dot both those files. So now we just have the original files that we wanted, and I can use FSL View to take a look. Beautiful. So with this data, we can now load it in and start doing an analysis of our subject's data on those Nifty files. So that's the end of the first method. So you do that that transfer, that DCM to NIX command for each of the sessions for each of your subjects. If you think that's boring and tedious, I agree. And for this method, you can script it, automize it to make it a little bit easier for you. If you've downloaded, if you're collecting your data in the class, we'll name your subjects on XNAT in a certain way, and that will make it a lot easier for you to actually download the data. So I'm going to cover that method now. Now that we've saw the manual and what I think of as a tedious method. Apologize in advance for the people that had to download their data with that way, or this way that I just talked about. And let's move on to the second method. So, how we're going to work this is that I made a little notebook that I'll publish soon with this video inside it. And I'll walk through that. Is the XNAT download? Okay. So the little script I made, we're just gonna use it through Docker just to make sure everything's is installed correctly. So the learning objectives for this is to interact with Docker and understand how to download data from XNAT. So we've walked through the manual process. Let's see what the automatic process looks like. So the first step is to go to Docker Hub and make a profile for yourself. I've already made a profile, so if I remember my username and ID, I can sign in. And here I am. And what I have what's here on the Docker repository is XNAT downloader, and that is what we will be using today. And actually, I still wanted that open. I'm gonna open. Okay, so I guess this was open. Okay, good. So what we're gonna run, we're going to pull the image, and it will either download it for us, or it will say that it's up to date since I've downloaded it before. And then we're going to test it to make sure that it works. Alright, it gives the help information that we wanted, so that is exactly what we needed. And it looks like that there are some updates that I haven't pulled yet. So I'm going to leave this page and shut down this notebook. I'm just going to type git pull origin. Alright, so now we're going to open up this notebook again. And now to actually use this program, we are going to configure a JSON file, which again is just a file that follows a certain syntax where all the contents are between these curly brackets, and we can embed as many curly brackets as we want, but for today's purposes, it's just a simple JSON file with a couple keywords and their values all specified within this pair of curly brackets. So what we want to do is that we want to make sure our server is pointed at the University of Iowa server. Okay, so that's already set up the way that it should be. Our destination is now going to be in a directory in which we want to download the DICOMs and convert them to Nifty format. And finally, the project is going to be named whatever the project name will be. Okay. So a question you might have is why the destination is in this root directory called out. And to explain that, it'll be useful to talk a little bit about Docker. So this is probably overkill for how we want to just run this script, but just to make sure that we are running it in the right environment, I've installed the script on a Docker container, and what that is essentially, it's kind of like a virtual machine that you've been using for class, except it's, I guess I would say, a lot more streamlined and containerized. So it only springs into existence when we call it, and then as soon as it's done, it tears itself down, and then it doesn't exist anymore, except on our disk. So essentially what we're doing is that we're calling another Linux operating system on top of our virtual machine's Linux operating system. So it's like a box inside a box. So that's pretty wild. And what we'll be doing is pulling information that we'd like to access in our virtual machines directories and exposing them to the Docker container. So what that means is that the Docker container by default doesn't have any access to any of the files on our virtual machine. So we have to explicitly tell it to have access to that. And what I will do is my command that I would be running would specifically, would look like this if I had the XNAT download in the labs.jdkent directory. But I will be using this command as a template to make my actual command, which should run in the terminal. Oh, and I did miss an important step up front here. Before we can run XNAT downloader or pull it from the Docker Hub, we need to open up the terminal and type sudo docker login. Okay. So again, it has my username and password, and it'll say that I have Docker ID, and we need to be able to log in to push and pull images from Docker Hub. So we're going to be pulling the XNAT downloader image. Alright. That was an important step. If you miss it, you just have to do that step if you want to move on to the next steps. So again, the final command that we're going to be running here is actually running the sudo docker run with our container. So I need to change some things just to make sure that there's not a conflict. So I'm going to cd into the UIOMRI course. I'm just going to move data to manual data. And then I'm going to make dir data again. So I'm going to select all the code here. Then I'm going to paste it into my terminal. Again, Control-Shift-V. I'm going to hit Control-C so I can edit some of the information that I've put out. And then that doesn't copy everything, so I'm going to select this last line here. Control-Shift-C, Control-Shift-V to get that last line of information. And I still want it to output in out. And the information is not going to be from there. It's going to be from testing, labs, XNAT download. Alright. And I'm just going to mount that within the Docker container as a root directory called JSON. So then when we specify the actual command, so this is when we're calling the container, and then all the options are being passed into the container as it sees itself. So everything is now, we're assuming it's operating within the file system of the container instead of within the file system of our virtual machine. So I can't specify home, brain, testing, labs, whatever, after I specify the container, since it doesn't know, and it doesn't have access to those directories unless we explicitly say so. And that's what we do with these -v options. So now instead of typing out the home brain testing labs XNAT download name of our JSON configuration file, I now have mounted that to a root directory called JSON, and then so for my input, I just specify the input JSON download config.json. So I'm going to run this right now, and I'm unsure if it's actually configured the way I need it to be configured. So actually I'll double check that. So I'll go into testing, go into labs, go into XNAT download, and I will just cat the contents. So yes, it looks like it is configured the way, so that's the UIOS server. Just going to push everything into rout, which we mounted as our data directory in our virtual machine. And the project that I'm going to download from is bike extend. Again, this will be different for our actual class, but this is just for demonstration purposes. So now that I have the Docker command all set up here, I can hit enter, and it will ask for my user information. So again, just when we logged into RPAX or the XNAT server manually, we also need to log in here. So, and if I type that in right, it should hang for a little bit, or look like it's hanging, but it's actually doing work in the background. It's just not being very verbose about it, and then it should start talking to us as soon as it started to download some of the files it needs. And then when it starts downloading, it'll automatically run the DCM to NIX command that we set up. And it will convert those files automatically for us into the nifty format. So to see how that's doing, we can cd into the UIOA data, and we can see that there is a source data folder as where everything's getting downloaded. Slowly but surely. And if we cd into the directory here, you can see that things have been converted into the file format that we want. All nifties. And this will eventually chug through all the data that we need. It will still take a while, but eventually it will convert all the data. And then we can start our analysis. So checking for data quality. If we did a task, then we'll need to additionally conform and extract data from our behavioral data files, etc., so on and so forth. And I think that is all that I need to cover, or wanted to cover for this one. So this will continue to download all the session and file information for this subject, and it will do it for all subjects if we have multiple subjects. So this will be a nice automatic way of downloading all the subject's data onto your local machine, and it will transfer into nifty format for you. So again, I find this way to be a lot better than having to click into each session, clicking download, and manually reconstructing each one to name it correctly. But for some of the people that aren't collecting data, for the class and the data is already on XNAT, you'll just have to grin and bear it and get through it. Hopefully, if I have time, I'll probably make a short little script or help you make a little automation script for the DCM to NIX portion so that you can transfer the data into a nifty format a bit easier. Alright, thank you for listening. Good luck and happy imaging.